This lesson is 5.3, Graphing Radical Functions. To start, we're going to talk about the parent functions. So we have radical functions, like this one is the square root of x, right? The radical x. And I could pick really any kind of numbers I want, but I'm probably going to want to pick perfect squares to make it easier. Also, we should remember that we're not allowed to take the square root of a negative, so I'm going to want to start this at 0. So I'm going to do 0 because that's technically a perfect square, then 1 because that's a perfect square. My next perfect square would be 4, then I would have 9, and then even though it's not going to fit, I'm going to put 16 there because maybe with my transformations it eventually will. And now we know we're going to take the square root of each of these numbers, right? So y, or really f of x, right? We're going to have y in all these pictures just in case, but f of x. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. So when I graph this, I'm going to have my 0, 0, I'm going to have my 1, 1, my 4, 2, my 9, 3, and I'm not going to be able to fit that 16, 4, but that's okay. And I'm not allowed to have negative numbers, so I'm not going to draw an arrow that way. I'm going to start it here. I'm going to just draw it in this direction. So that means for our domain, since we're not going to put any negative numbers in, x has to be greater than or equal to 0. And because I'm also not getting any negative numbers here, my range is going to be y is greater than or equal to 0. Right? And that's our parent function for the square root of x. Now we'll look at the parent function of the cube root of x, right? This is still radical functions, the cube root of x. We're allowed to put positives and negatives in. So I'm really going to put my 0 in the middle, and then I'm going to think, what are my perfect cubes, right? 1 to the third power is 1, 2 to the third power is 8. And negatives are allowed, so I'll make it -1 and -8. Right? I could really pick any numbers here, but then I'm going to get some messed up numbers for my y's, so I want to keep it as simple as possible. So the cube root of -8 is -2, cube root of -1 is -1, cube root of 0 is 0, of 1 is 1, of 8 is 2. So I'm going to graph -8, -2 here, -1, -1, 0, 0, 1, 1, and then 8, 2. All right, let's see, this is a big one. Let's see if I can get it done. So we're going to have arrows on both ends, and it's going to look something like this. All right, I'm allowed to put any numbers of x in, so my domain is going to be all real numbers. And there's not going to be any restrictions on my y's either, so my range is also all real numbers. All right? So now we're going to look at the different transformations. We know from when we transformed our quadratics, horizontal translations, horizontal left and right, was inside parentheses before, so now it's going to be inside our radical. And it's always kind of the opposite, right? You do the opposite of your x. So x minus 2 is really 2 units to the right. X plus 3 is really 3 units to the left. Vertical, that's our up and down, right? Vertical. And that happens outside the radical now instead of outside the parentheses. So plus 7 is 7 up, minus 1 is 1 down. We do exactly as they say for vertical. For our reflections, if it's with it inside the radical, it's a reflection on the y-axis, and it would happen to the x value. If it's on the outside, it's a reflection on the x-axis, and it would happen to the y value. Then we have our stretches and shrinks. I'm going to talk first about our vertical stretches and shrinks because those are the ones we started with last time. So if there's a number on the outside, right, it used to be outside the parentheses, now outside the radical, whatever that number is what the factor is. So a 4 on the outside is a factor of 4. A 1/5 on the outside is a factor of 1/5. And then anything bigger than 1 would be a stretch, and anything between 0 and 1 would be a shrink. On the inside was where we got our horizontal stretches and shrinks. And if you recall, we would take the number that was in there and turn it into the reciprocal first before we declared what it was. So, right, this reciprocal of 3 is 1/3, which would make this now a shrink by a factor of 1/3, right? A horizontal shrink. And if it was 1/2 inside, the reciprocal of that would be 2, so that would be a stretch by a factor of 2. I know it's been a while since we've done these, but let's just try to describe what's happening in each of these, right? So we're looking at inside with the x, so that's our horizontal translation. I'm just going to put H translation. All right, horizontal translation of 3 to the, and remember we're going to do the opposite. Minus 3 is to the right. And then on the outside, the plus 4 is our vertical translation. 4 units, and we do exactly what it says, up. All right, we look at our next one here, and I have a -8 on the inside. So we said when the negative's on the inside, that's really a reflection in the y-axis. So we have reflection, y-axis. And also, if the number is with the x, that is our horizontal stretch or shrink. So we know it's going to be horizontal. And 8 would be really be 1/8. So if we're looking at 1/8, we're looking at a shrink by a factor of 1/8. Remember, the negative is part of the reflection. We're only looking at the actual number of 8 to describe the horizontal stretch or shrink. If we look at C here, we have a 2 on the outside. That is a vertical and it's bigger than 1, so it's a stretch of 2, factor of 2. And inside with the x, we have plus 4, so we know inside is really our horizontal translations. And we do the opposite, so plus 4 really means to the left 4. For our last example here, we have a negative on the outside. That means it's a reflection in the x-axis. All right, reflection. Oh, that was a bad one. Reflection in the x-axis, and then on the outside we had -6, so that's a vertical translation of 6 down. All right. So what we're going to do next is we're going to describe the transformation that is happening, but then we're going to actually start to graph this. So we notice our parent function would have been the square root of x, right? That's what it's looking like here. Inside we had +2, so that was our horizontal translation of 2 to the opposite left. And outside we had -3, so that was our vertical translation, 3 down. And I'm going to want to put my parent function for the square root of x. So if we go back to the original, I'm going to just look at this again real quick. We had 0, 1, 4, 9, 16. So that's what we're going to do here. 0, 1, 4, 9, 16. And now these are all the square root of that. So that was 0, 1, 2, 3, 4. Now if you recall, anytime I'm doing something to the x, I'm doing the opposite of it here. So if this was x plus 2, this column is going to become x minus 2. And anything that happened to the y happens exactly as it was, so that -3 is going to become y minus 3. And we're going to transform these numbers into this column and these numbers into this column. So we're going to take 2 away from everything here. So that's -2, -1, 2, 7, 14. looks like we still won't be able to graph that, but that's okay. And we're going to take 3 away from each of these. So negative 3, negative 2, negative 1, 0, 1. So that gives me the point negative 2, negative 3, negative 1, negative 2, 2, negative 1, and 7, 0. Remember, with our square root graphs, we're not going to put an arrow. We're only going to put it in the one direction, and it's going to look like that. So now I could see that my domain is only going this way. It's all of the x values greater than negative 2. So x is greater than or equal to negative 2. And my y values are all above this one, right? The negative 3 here. So y is greater than or equal to negative 3. Note if we had any sort of reflection and it was going down or something like that, that would change our symbols here for domain and range. All right, you're going to pause. When you're ready, restart, and you can see the answer. All right, if you're back, we have a horizontal translation, 5 right, and a vertical translation, 1 up. We're going to put our parent function. We're going to put our transformations. So that's going to give us here 5, 6, 9, 14, 21. We're obviously not going to graph these last two. So we have 5, 1, 6, 2, and 9, 3. Domain is x is greater than or equal to 5, and range is y is greater than or equal to 1. Okay? So now, again, now we have a cube root as our parent function, and we're going to describe the transformations, graph it, and state the domain and range. So we have a negative on the outside, so that's a reflection in the x-axis. And then we have a 2 on the outside, so we know on the outside means vertical because the number is bigger, right? This number here is bigger than 1. It's going to be a stretch of 2. All right. Remember my parent function here was negative 8, negative 1, 0, 1, 8. And we had negative 2, negative 1, 0, 1, 2. Right? If we look back at that original one, that's what we had for our parent function of the cube root of x. And now my x is not changing. Nothing's happening at all to my x. But my y's are getting negative 2 times them. So all these get to stay the same. Okay? And we're going to multiply each of these by negative 2. So negative 2 times negative 2, we get positive 4. Negative 1 times negative 2, I get positive 2. Anything times 0 is 0. 1 times negative 2 is now negative 2. And 2 times negative 2 is negative 4. So what this is going to look like is we're going to have negative 8, positive 4, negative 1, positive 2, 0, 0, 1, negative 2, and 8, negative 4. All right, remember arrows both ends for cube root. And we have our graph. All right, probably definitely not as straight here as I would have done normally, but should be a little more curvy, right? Our domain for our cube roots, all real numbers. Our range, all real numbers. All right? Try another one together. This one has the 2 on the inside. We know that that means it's a horizontal stretch or shrink. And if it's a 2, we're going to take the reciprocal of that. So that's 1/2, so that's a shrink. Horizontal shrink of 1/2, factor of 1/2. And then the -4 on the outside is a vertical translation 4 down. Okay? Our parent function here was the square root, right? So we're going to pick 0, 1, 4, 9, 16, 0, 1, 2, 3, 4. Remember, anything that happened with the x is going to be applied to the x, so that's really this 1/2 here, 1/2 x. And then anything that happened to the y's happens to the y exactly, so y minus 4. So we're going to take half of each of these numbers. So for some of them, that's going to be nice. Others, it's going to end up being fractions or decimals, right? Half of 1, 0.5, or 1/2. Half of 4 is nice, right? That's 2, but half of 9 would be 4.5. Half of 16 is 8. Looks like we could finally graph that one. Yay! All right, so now we're going to take 4 away from each of these. So we get -4, -3, -2, -1, 0. All right, so now let's graph these. We have 0, comma, -4. We have 1/2, comma, -3, so it's going to be right about there. We have 2, comma, -2. We have 4.5, comma, -1, so it's 1, 2, 3, 4 and a half, -1, and then 8, 0. Remember, square root doesn't get the arrow on both sides, just the 1. So that's how we'll graph it. So now my domain is still x is greater than or equal to 0. Right? Always looking at this first set of numbers here. And my range is going to be y is, again, it's going up, greater than or equal to -4. So you're going to go ahead and give this next one a try, pause it, and when you're ready, you check your answer. All right, so if you're ready to check, the negative on the outside is what tells us we have a reflection in the x-axis. The 2 on the inside is a horizontal, and it's 1/2 really, so that's a shrink of 1/2. We know the parent function is our cube root. So that's -8, -1, 0, 1, 8, -2, -1, 0, 1, 2. So the negative is to the y because it's on the outside. The 1/2 is to the x because it's on the inside. So this is where we're going to have -4, -0.5, 0, 0.54, and then change all the signs of my y's. All right, we have -4, 2, 0.5, -0.51, 0, 0, 0.5, -1, and 4, -2. So again, arrows both sides for a cube root. Ooh, I'm darn proud of that one this time. All right, domain. We have the, actually, remember domain and range always all real for our cube roots. Last kind of problems is we're going to now write the function given the transformation. So we're just going to work backwards. So we know that we're writing the function g of x, and we're transforming the square root of x in these problems. So a reflection in the x-axis is a negative on the outside. Vertical stretch by a factor of 3 is also a 3 on the outside. And I'm translating right, so that's going to be in my square root. So this is going to be x, and then 6 right is really minus 6. And that would be my answer. So for B, again, I'm going to start with g of x equals, they're telling me a horizontal stretch by a factor of 2. So that's going to be inside the radical. And if it's by a factor of 2, remember we do the reciprocal, we're going to put a 1/2 in here. And then translation 3 units up is outside, so we're going to get plus 3. All right, for the last one, give it a try, pause it, and when you're ready, check your answer. All right, if you're good, here is our answer. Remember we were transforming the cube root this time? And there you have it. That is graphing radical functions.